we're going to count functions in this video. Let me start with the definition of a function. You've seen this before, I know, in other contexts. It is the same kind of thing. A function from a set A, which we call the domain, to a set B, which we'll call the codomain, is a rule that assigns to each element of A single element of B. This definition is one that came about after a long time as mathematicians considered what they meant by function, and it's the one that really works best. Notice that the sets A and B aren't particular types of sets. They can be any sets. They don't have to be sets of numbers. So this is a little more general than you may have worked with in previous courses. Let me continue with the definition. We often name a function, and if we call a function f, we'll indicate that f is a function from A to B by this notation here, f colon A to B. So A is the domain here, B is the codomain. A function from A to B, f from A to B, is one-to-one in case the output values being equal imply the input values had to be equal. Equivalently, that says if you have different inputs, if x and y are different in A, then their outputs are different. F of x has to be different than f of y. Those are logically equivalent. You can kind of think that through and see why those two things are equivalent. So for our purposes, I might just take a little time here to sketch a function or two. So for example, we might have A, and in a finite case, it's pretty easy to sketch how a function might work out. Maybe A has the elements 1, 2, 3, and 4, and maybe B has letters as its values. So maybe B has the letters A, B, C, D, and E, say. And so the function I'm going to indicate by using arrows to indicate where are the assignment. So 1 has to have an element of B assigned to it. So maybe 1 has C assigned to it. So we think of 1 goes to C, that's the arrow there. And 2 similarly has to have something assigned to it. So maybe 2 goes to A. So the assignment there of the function is A is assigned to 2. And only one thing gets assigned to 2. 3 might be assigned to, say, B, and perhaps 4 is assigned to E. So nothing, or D is not assigned to anything here. But this would be the function. Now in the function notation, what this would say is f of 2, for example, is equal to A. Yeah, f of 3 is equal to B, using the kind of function notation that you've used before. In order for this to be a function, there is a single element of B assigned to each element of A. So what would be incorrect would be to have something like this. We could not have 2 also assigned to D, so this would be no, right? In the case of graphing in the plane, that corresponds to the vertical line test. But here, there's no lines, there's no plane. There's just the assignment here of what a function does. Right, so let's do a little bit with this. How many different functions are there from a set A to a set B if the first set A has m elements and the second set B has n elements? These are for some positive integers m and n. So we're going to try to count these functions, and we're going to think about how to construct the function. So we have A has A1, A2, M, and B has B1, B2 through Bn, say like so. So now how do we construct this function? This is really good to keep in mind because sometimes these formulas are hard to remember and they're not as useful as remembering strategies anyway. So the function is constructed, remember, by deciding what we assign to A1, what arrow we draw here from A1. So we have to decide where does A1 go? So in terms of the schema here, I'm going to say, okay, what happens to A1? Where does it go? How many choices? Number of choices. To assign. Well, there are n, this is the letter n as in neighbor. There are n choices there. And then we'll similarly do that for A2. Where does A2 go? How many choices for it? Well, it still has the same number of choices, n. And for each of the elements in A, we have to make an assignment from the n elements of B. They don't have to be different elements for different things in A, but what we'll have right here is n possible choices for each of those. And if we take that product, we get n, but there are m factors of n. Okay, yeah, so there's this formula, n to the m, where n is the number in the codomain, number in the codomain is the base there, and m is the number in the domain. Okay, and next we'll talk about how many of these are one-to-one, but I think I'll go ahead and stop this video clip, and then we'll come back and do that in the next one.